Across the United States alone, there are roughly 300 million discarded tires sitting idle at this very moment. They are stacked behind gas stations, piled in narrow alleys, dumped in vacant lots, scattered along rural highways, heaped in junkyards, and leaning in quiet rows against the walls of auto repair shops in nearly every city and small town. In the modern world, they're classified as waste, ugly, bulky, stubbornly resistant to decomposition, and costly to remove. They collect rainwater, attract mosquitoes, and occupy space nobody wants to give up. But in a post-collapse world where supply chains fail and manufactured goods disappear, a single car tire transforms into one of the most valuable raw material stockpiles you could ever encounter. The irony is simple. The exact characteristics that make a tire such a headache as garbage are the same qualities that make it extraordinary as a survival resource. It was never designed to break down. It was engineered to endure punishment that would destroy nearly any other material you can scavenge from an urban landscape. A modern passenger tire is not just rubber. It's a composite structure made from vulcanized rubber, advanced synthetic polymers, layers of woven nylon or polyester fabric, and tightly wound high-tensile steel wire. Every component was selected to resist cutting, tearing, puncturing, abrasion, ultraviolet radiation, chemical exposure, extreme heat, freezing cold, and constant mechanical stress. It was built to support a 2-ton vehicle traveling at highway speeds over rough pavement for 50,000 miles or more. That level of engineering doesn't disappear when the car is gone, it becomes available to you. When infrastructure collapses and stores are empty, strength and durability matter more than appearance. A tire offers materials stronger than wood, more weatherproof than fabric, and more resilient than most scrap metal you'll find. And the supply is effectively endless. They're free, they're everywhere. And most people ignore them because they can't see beyond their original purpose. From one single tire, you can build solutions to 5 fundamental survival problems: water, footwear, wire, fire, and fastening. Tool number 1. Convert the sidewalls into durable water collection and storage vessels. The sidewall, the flat section between tread and rim, is a dense disc of layered rubber and reinforcing fabric roughly 3/8 of an inch thick. It's completely waterproof, flexible enough to shape, and tough enough to hold water for years without cracking or leaking. Using a sharp knife, hacksaw, or even a serrated kitchen blade, carefully cut along the seam where the sidewall meets the tread. Remove both sidewalls and you'll have 2 broad rubber discs. Press the center of each disc into a shallow depression in the soil, a hole you've dug, or a frame made of rocks and sticks. Instantly, you've created a basin. Depending on tire size and depth, each sidewall can hold 2 to 4 gallons of water. That means one discarded tire can provide 4 to 8 gallons of storage capacity. In a world where clean water determines survival, that's significant, but storage is only part of the advantage. Collection is where the sidewall truly shines. Lay it flat during rainfall and it becomes a catchment surface. The non-porous rubber funnels every drop toward the center. Unlike fabric or soil, it doesn't absorb moisture. The water pools naturally, cleanly, and predictably. Position several across open ground during a storm and you can gather substantial quantities of rainwater without specialized tarps or containers. Cut into strips, those same sidewalls can line a dugout pit, forming an improvised underground cistern. Overlap the layers along the bottom and sides, press them firmly into place, and you've created a waterproof liner capable of holding hundreds of gallons. Underground storage keeps water cool, concealed, and protected from evaporation. What was once roadside waste becomes a long-term water system. Tool number 2. Reshape the tread into nearly indestructible footwear. The tread, the thick, patterned outer ring, is the most heavily engineered section of the tire. It was built to grip asphalt under immense weight, resist grinding friction, and withstand temperatures ranging from below freezing to blistering heat. Cut into flat panels, it becomes the toughest sole material you can produce without industrial equipment. This practice isn't hypothetical. For decades, communities in harsh environments have worn sandals cut from tire treads because they outlast conventional shoes many times over. The rubber simply does not wear down under normal human movement the way leather or foam does. Cut a section slightly larger than your foot, about 2 inches longer and an inch wider on each side. Punch holes near the edges using a heated nail, knife tip, or sharpened metal spike. Thread cordage, wire, strips of rubber, or salvaged laces through the holes to create straps. A 3-point strap system across the toes, around the ankle, and diagonally connecting the two creates a stable, secure fit suitable for walking, climbing, or running. Construction takes less than half an hour. The result may last for years. In a collapse where transportation means traveling on foot across debris, broken glass, and rough terrain, protecting your feet becomes a frontline priority. Without mobility, everything else fails. Tool number 3. Harvest the steel bead wire for high-strength metal applications. Along the inner rim edge of every tire sits a tightly wound bundle of steel wires known as the bead. This component locks the tire to the wheel under extreme pressure. It's made from high-carbon steel, drawn fine, yet incredibly strong, capable of resisting thousands of pounds of force without deforming. Cut around the inner rim where the rubber is thickest. Peel it back and expose the wire bundle. Using pliers or leverage, extract individual strands or remove the entire ring and unwind it. From one tire, you can obtain roughly 15 to 25 feet of resilient, springy steel wire. That wire can be formed into small game snares, fishing hooks, sewing needles for heavy materials, trap triggers, structural lashings, and spring mechanisms. Heat makes it easier to bend, stone sharpens the tips. Twist multiple strands together and you have a cable stronger than most store-bought wire. Its spring quality allows it to maintain tension without losing shape, making it ideal for mechanical triggers and latching systems. Tool number 4. Use the rubber as a powerful fire accelerant and heat source. Tire rubber burns intensely and for a long time. While the smoke is thick and unsuitable for stealth, it is highly visible for signaling and highly effective at driving away insects. Shave thin strips and place them beneath kindling. Ignite with spark or flame. The rubber sustains high temperatures long enough to ignite damp wood that might otherwise fail to catch. Larger chunks can burn for extended periods, generating significant heat for boiling water, heat-treating metal tools, or maintaining warmth in freezing conditions. Used carefully and in moderation, it becomes a reliable ignition booster when natural tinder is scarce or wet. Tool number 5. Cut the remaining tire body into rubber strips for versatile lashing and fastening. These strips stretch under load, grip smooth surfaces through friction, and retain elasticity in nearly any weather condition. Unlike rope, they won't rot in rain or stiffen permanently in cold. They absorb shock instead of snapping under sudden strain. Use them to secure gear to packs, reinforce shelter frames, attach tools to your body, bind structural joints, or construct small hunting devices like slingshots. Their flexibility allows structures to move slightly in wind without failing, increasing durability over time. Break down a single tire completely and you gain 2 waterproof basins solving water collection and storage, enough tread for durable footwear solving mobility, 15 to 25 feet of high tensile wire solving trapping and tool needs, abundant rubber fuel solving ignition challenges, and extensive rubber strapping solving fastening and structural problems. 5 core survival challenges: water, protection, metal tools, fire, and binding, addressed by one object discarded in plain sight. Most people overlook tires because they search for gear that looks like survival equipment. They miss materials that function as survival equipment. The difference between scarcity and abundance often lies in perception. What appears to be waste may actually be a cache of engineered resilience waiting to be repurposed. A tire is not trash. It never truly was. It is a survival kit designed by advanced material science, disguised as something disposable. In a world where resources are limited, learning to see value where others see junk could mean the difference between struggling and adapting. Stop walking past it.